All right, so I'm going to be talking a little bit about using CouchDB over BigCouch with Kazoo today. This will be a little bit technical. There will also be a whole lot of stuff to not do that also happens to apply to BigCouch, but it's kind of a what's gone bad, what's gone good kind of thing. And just out of curiosity, for a show of hands, is anybody else using CouchDB over BigCouch this one? Great, that's awesome. So I hope you guys have had some good experiences with it over BigCouch. I'll just go through what we've gone through. So
computers are hard.
Yeah, I don't know apparently how to move between slides in PowerPoint. So I'm just going to start off with why replace BigCouch if you're still using BigCouch. There's just a couple elements to this that are actually pretty important. Support. BigCouch is definitely no longer supported, and it hadn't been even well supported at the time where it was what everybody was using prior to CouchDB 2. The biggest one is the underlying version of Erlang has been upgraded in BigCouch to R19, or of CouchDB is R19. The R15 that was previously included with BigCouch actually suffered from a lot of memory leaks, and there were other scenarios that could just basically nuke your database server without doing anything wrong on your part. And all relevant features at this point have been ported to CouchDB, and the main reason for BigCouch before was the clustering feature, so that you can have distributed systems. I'm going to just go over migration to CouchDB 2, just a series of steps that you might do. Don't just try to straight up copy your SRVDB over. That ain't going to work. They've changed the format, so don't do that. For all context here, we're using the 2.1.1 release of CouchDB, so some of the problems that we're encountering at this point might be solved. I think there's a 2.1.2 out already, but we haven't tested it. But I'll talk about what we've gone through. So procedure. So the way you're going to want to do this, if you haven't already, is you're going to want to roll completely fresh Couch 2 servers and customize those or configure those for clustering initially. Make sure you follow the cluster documentation in CouchDB. It explains it well, and they will comment on the fact that you want to predefine the size of your cluster ahead of time. You want to know how many nodes you're going to need. You want to know how many shards you're going to use. And that'll vary depending on your size, your geographic placement. And perform a one-time replication from your old BigCouch cluster to CouchDB 2 using the built-in replicator tool. That'll be the easiest way to do that. It's a one-time because you're going to do one big batch to start, and you'll probably want to switch to a continuous replication job just before your cutover, so that during cutover you make sure everything's in sync, and then turn the key, and then you'll be on Couch 2. Node configuration. If you're going to use the Kazoo configs BigCouch repository from 2600 Hertz, that's fully compatible with CouchDB. There's no change in the configuration file format, so you can do that. They have at this point released Kazoo configs CouchDB, which is honestly just a copy of the repository and essentially no changes except for naming of the nodes and some of the file names and file paths. Fun fact, RW values were meaningless in BigCouch 0.4.2. And I actually couldn't figure out if this has changed in 2.1.1 because I haven't looked at it in a while. So if anybody has some knowledge on this, I'd love to hear about it.
R and W are still ignored.
They are still ignored. Okay, so I'll go on about that in a short time. Sharding, you're going to, if you're big scale, you have customers that make many thousands of calls, you're going to be wanting a Q value that's a little bit higher than 1. I'll explain the benefits of that in a bit. If you're smaller, you can get away with 1. That is fine. I would recommend you use the wrapper scripts provided by 2600 Hertz. They are in the one repository, Kazoo BigCouch. The other one's Kazoo CouchDB. They do essentially the same things, which is set system limits on the fly before you start it. If you don't, just set them yourself. That's fine too. We are moving towards using it soon, just for consistency with how 2600 is doing it. Obviously nice to not diverge as much as you can avoid. So I'm going to go over cluster configs and talk about RW. So for those of you that don't know, Your Q value defines the number of shards you have per database. A higher value will reduce CouchDB's memory overhead when you get into very large databases, though you don't want to go too high. When you define, say, Q is 4, it will divide the database into 4 shards, which hold a portion of the data that's hashed into that bucket, essentially. But if you get that value too high, there is a good chance that docs that are requested by a user are not already loaded in memory, so you're going to increase your disk activity. That will bring your performance down at a certain point. So it's kind of a juggling act between how much memory have you provisioned for these servers versus how much do you want to hit the disk and that kind of thing. N value is number of copies or replicas of documents in the database. Doesn't necessarily match how many nodes you have. I think there was a common misconception that N meant nodes. It's copies of documents. So extra, higher value of N ensures redundancy, and your total max number of nodes is going to be Q times N. You actually cannot have more nodes than that in your cluster. By default, what 2600 Hertz is recommended is you have an N value that is in fact equal to your number of nodes. It just means there's one copy of every shard on every one of those nodes. If you're having maybe disk problems, you could potentially go higher than that. So if one copy gets corrupted, you still have another copy, but keep in mind you already do have many other nodes that can pick up the slack in those cases. RW, so R is respectively the number of nodes that have to agree on the document revision before that doc is returned to you when you make a request. And W, on the other hand, is the number of nodes that have to agree on the revision that you're updating before they're written across the cluster. As Dayton confirmed for me, these values are and were ignored. They actually internally all end up being n over 2 plus 1. It does not matter what you set in your configuration. So definitely leave it out because it doesn't do anything. The default value makes sense because it ensures consensus. You will never have a situation where a partition of your nodes can agree on a document revision and another one can agree on it, and then they can't come to a consensus when you have a majority RW value in that sense. Presumably they made that change at some point just because people were encountering those problems and just not figuring it out. So now it's hard-coded to be n over 2 plus 1. Works great in practice though. I will talk about a caveat of that later. And I'm not bringing the next slide. There we go. So the good and the bad, it's not always sunshine and rainbows. In fact, it's really funny. I have about 4 slides of bad and 1 slide of good. It just kind of worked out that way.
But like the weather in San Diego.
Exactly, 4 out of 5 days. So the replication tool is the first thing. One minor issue is it's not really any more robust than it was in BigCouch. They have a slightly new UI for it, but that's not really that useful, I suppose. And it's kind of buggy. We are running a large number of continuous replication jobs right now, and the port 5986 half of CouchDB will go down due to memory exhaustion. And very often, very suddenly, it seems to happen all of a sudden with very large databases, those with typically MODBs in the case of Kazoo with like 400,000 docs or more. We'll get to them and it will just take down the node. If you're using systemd, it obviously comes back up right away, but it is a pain because it does it almost continuously as soon as it gets back into running those continuous replication jobs. That overall slow memory leak apparently is just in general. That's good to know. So we'll have to communicate on that. Also, the replication tool doesn't handle error cases very well. For example, I'm trying to repair some databases. I have a slide about how we got into that situation. And if a document in the shard or the _DB's like shard file database on one of the servers doesn't exist and you try to replicate there, but the file exists on disk, it doesn't know to just create the DB shard file and then let you finish replicating to that database. It actually just fails silently on your replication host, but you'll actually see the error logs on the server that it's trying to write to. It'll say shard file already exists. So there's just no handling of those error cases. If you run into problems where things just stop, go take a look and see if your destination is throwing some sort of error for that shard. What's that?
Same.
Yeah, I just, you know, for the people who haven't done it before, I'm sure it's good to know. Also, it's not a bug, it's a feature. Continuous replication jobs pause and they switch around in a round robin fashion. At first, I thought they were all supposed to be simultaneously running, and I was like, why does my active tasks show only a portion of my continuous replication jobs? It's for memory and CPU reasons. They stop some jobs and they start others up. You can't trust it to be real time ultimately, which is a pretty big caveat of that.
So another thing that we should probably ask, particularly Graham, if you're using it, one of the things, and Daniel, correct me if we haven't done this or if we have done this and this is still true, there's a whole series of tunables that are that's in the replication API for like how many workers you can have, what the thread pool is, what the backoff time is, and they've in 2.1.1, I think, introduced a replication scheduler that they claim that they've put a shit ton of work into to get around some of the things that we're talking about. Now, I don't know if it's like fundamental core bugs or if these things have been able to be tuned a little bit better, if they behave better or not.
We haven't experimented with it yet. Obviously, you know, if you can schedule around times where you might want your data to be more real time, for example, it's business hours of a location in the world, you might say, okay, make my continuous replication jobs active during that time. And maybe the tunables, you can probably get a few more active jobs, but there are memory constraints naturally. I mean, if you get 30 gigs of memory, you might be okay, but you don't have ours that big. So it'll be tunable probably, but you will not get a situation where you can just have them all going simultaneously and have everything real time through a replication job. It's not designed to do that.
So you use the replication just across the WAN, basically, right?
Yes,
So this
yes,
is not,
we do.
This is not the clustering. So the clustering is the same as BigCouch. This is for you. The reason you do this is because you have an unreliable network connection.
Yeah, we have data centers in San Jose and Melbourne, and doing clustering over that. Nah.
Yeah.
Well, we should go into a specific about why you should never, ever, ever cluster over the WAN.
Just let me get to the next slide. Clustering over the WAN, don't. Funny history, 2600 Hertz recommended you cluster your BigCouch nodes across the WAN so you'd have consistent data between your zones, which sounded good in theory until you find out from the official developers of CouchDB explicitly tell you, don't do this. It's not designed for it. It can't handle latent connections, pretty much anything above about 100 milliseconds, it won't work. It will add that latency to, in a good, you know, in most scenarios, to every time you do a read or write operation. And network partitions can lead to the quorum not being met. Documents won't write, reads will be slow. Reads are slow because if it can't meet quorum on a read, you'll still get something, but they will note with the status code that the quorum was not met, but here's what we think we can give you, and writes just won't be performed. So we used to have a setup where we had 4 nodes of 4 database server nodes in Vancouver, 2 in San Jose. Quorum on that setup is 4 nodes. So what would happen is if we had a network partition between Vancouver and San Jose, anything going on in San Jose could only ever meet 2 out of the minimum of 4 for quorum. So San Jose was essentially down when that happened. So the solution is, well, let's just do continuous replications or some other solution. That's how you will handle federated accounts, is you have to find some solution to that problem. Right here. Everybody's just like one step ahead of me here. It's so excited. Yeah, I know. So integration with Kazoo and federated accounts. So as I mentioned, we need to find a solution to handle this across the WAN. We were proposing to start a project that's a core module for Kazoo that actually lets you manage continuous replication jobs at a per account level. So for an account and its corresponding MODBs, you could say, I would like this account to be present in zone 1, 2, and 3, but not 4 and 5, or something like that. You can pick your locations depending on the actual needs of that customer. But it may be problematic given our issues with the replication tool, its inability to handle error cases, its lack of being real time, but maybe we can piece together things like the scheduler and that to make it happen. There's also a project called Spiegel, and they're tagline is scalable replication and change listening for CouchDB. We're going to explore this as part of this project. In the README on that repository, they do talk about how you can use Spiegel to manage this stuff over wide area networks. So we're going to give it a go and I guess give you guys some feedback on where we get to with that.
They specifically listed they've been using and testing it with tens of thousands of databases real time across the LAN.
Yeah.
But that's what it's built for. So
yeah, I think basically they say they're using the underscore changes doc or API off of every database, and somehow that ends up being more lightweight than just leaving the continuous replication jobs up. So they actually tear them down and rebuild them on the fly.
Yeah,
So
I can kind of see why that works.
yeah,
Well, I mean, we're not using change feeds properly in CouchDB. I don't think.
we're not, no.
Yeah, we haven't touched that yet, but in other database systems, we rely on it. And it even does deduplication for us by doing that.
Right.
In RethinkDB, we've been running it, and it works amazingly. So
Okay.
I could see, as long as we're looking at a particular timestamp forward, we're not going back in time.
Yeah, exactly. And that's actually an interesting thing. If you ever watch the active task screen when you fire up continuous jobs, even after like a restart or something, it actually starts over. It starts from like 0 and starts counting the docs. Oh yes, I have all of these docs, and then finally writes the newest little bit at the end. And that happens even when they stop and then they resume based on the round robin system. It's very inefficient. I don't know why it works that way, because even every database actually has an integer representing the sequence that they're at. So they could just carry on from that point.
So if it crashes on a replication job, it will basically never finish.
Yeah, potentially. Yeah,
It starts over and then
Yeah, exactly.
Same point crashes, starts over again.
I'm running into that. So another thing is it's still not great for things like CDRs. The view model doesn't provide enough for things like a freeform search, which you typically do use for a CDR. Also, very large views are frequently unloaded from memory. For context, I can give you an explanation of the view model afterwards. I don't want to get too deep into how that works. And they take a long time to query when they're cold and they're out of memory. We are working, or rather Ben is working on a PostgreSQL KZ data manager backend that you can use as a drop-in replacement for MODB data or anything else, because it'll be general purpose. It'll probably involve an extension to data plans or whatever, to allow you to specify them on like globally for all MODB data by default, because right now you can tie those plans only to accounts and then things in those accounts, but there's no batch way, I think, to say that it's for everything. So we're going to work on that as another project as well, and hopefully CDRs will be much more functional after we get something like that done. Last one. This one is our bad. Absolutely 100% make sure you've configured your cluster correctly, and only the nodes that you are actually using in the cluster should be defined in the list of like your underscore membership list. We had extra entries from old unused node servers that weren't running.
they were never supposed to run.
They were never supposed to run CouchDB. It was a typo that somebody put in and thought it was an innocent mistake to leave them and not delete them after putting in the correct ones. Whenever a new database is created, a shard definition file is created for them, and it selects your end value databases at random from your list of shards. So we had 6 nodes that we actually wanted, but we had 8 entries in the membership table. So it would occasionally pick those servers and put them in there. Alone, that's not horrible. It means you have less likelihood to hit your quorum. It got really bad for MODBs, however, because frequently you'll find that one Kazoo server and another Kazoo server will try to initialize that MODB at the start of a month at the same time. Now, if based on the way you're proxying requests or load balancing them, you might have one node create them in a series of shards that doesn't match the series of shards that another one picked, those 6 random ones from the 8, for example. And now you actually have databases that aren't consistent. We discovered this way after the fact by running CDRs, getting a CDR view response, and then trying to pick out one of those CDRs and getting a 404 on it. Because first request would go to one that actually had it, and then the second one went to a server that did not have that doc. This was hell to patch after the fact. We ended up having to replicate all copies of the shards into one copy of the shard, and then update all the pointers by hand for every single database since this mistake was made. You're going to have a bad time. So make sure you get that part right.
We're like a month and a half into it and the script is still running.
Yes. Yeah, we're doing that on the fly right now.
Oh boy.
Yeah.
This is a weird case where that clone tool might be good.
I'm doing essentially the same thing. Yeah, and part of the biggest focus is I have to make sure I hit all the copies of the shard files on every node, because this one might have some data that this one doesn't. This one might have some data that this one doesn't. I have to merge it all, right? So I'm doing that. Obviously haven't lost any data, but like it's taking forever.
Clone tool an issue to use like in the migration scenario?
We still use it. Replication is, I think, a better way to go. But what we do like about clone tool is that we'll automatically not use older MODBs. Like we can clone the core config and the core account DBs. Those are the ones we want cut over right away. And then as soon as we do that, we can switch production over to a new cluster, and then we'll slowly catch up.
Yeah, I mean, I would recommend that. I guess I didn't put that in the previous slide there, but yeah, be selective about the databases you copy over, maybe the last month's MODB and the account databases, and obviously your numbers, and then do a catch up for the MODBs later. It doesn't matter.
Yeah, that's exactly what we do.
Yeah, just make sure you rerun a like subcaps maintenance migrate when you're done that, so that it updates the view definitions for all those databases.
Yeah, actually, that's what we create these.
Don't forget that. Yeah. And the good one slide, but actually really important stuff. My experience is it's overall way more stable than BigCouch. I didn't realize we were suffering from a slow memory leak, but we had a lot of sudden crashes when we were using BigCouch. I don't experience those anymore other than in my replication jobs. Support, it's obviously well supported now. Cloudin has a commercial product for this, but they also have a good amount of support. And you can get support on IRC, on the Freenode server, hash CouchDB. So they're all really good there. Also, Photon, the default new web UI, is I think much more robust. The table view is freaking awesome because you can actually select columns similar to how you might do in a SQL-esque fashion. Obviously, that's a little bit slow. So on big databases, you don't want to do that. But for just searching for like a list of users and you want to find them by name, very easy. They now have a DB search by name, so you don't have to type it in the URL, which is a pain in the butt. With Photon. One big omission for some reason, and I would like to actually make sure we do this soon, is add revision viewing support to it. There's no way to look at previous versions of the doc in the Photon web UI. And come on, it looks cool. It looks great. So
It does. It's a lot better.
yeah, it's very modern looking. So that matters.
Even just the DB search tool,
Yeah,
the
right.
default page is quite useful.
Yeah.
You've got a few thousand to go through.
Yeah, so I mean, it doesn't look like a lot, but moving forward, like the support, the stability, that stuff's really important. As much as you don't see a bunch of flashy stuff on the slides. Yeah, and that's it. That's what I've got. So, if you guys have any questions, if you want to know about like the view model stuff, I can explain that. But, yeah.
Do you know how 2600 Hertz does there? Because they've got a WAN, right? Or are their connections so point-to-point reliable or something? That
I believe that at this point they probably still have some stuff that's legacy clustered over the WAN, and then I also think they have a lot of customers that they just isolate to one zone.
So when you replicate between zones, what happens to Kazoo caches?
So that's part of the project that I was going to talk about there is you have to be able to manage your replication jobs and do federated cache flushing. I forgot to say that. So upon a document getting replicated somewhere, you have to publish something into AMQP that will trigger a cache flush on the other side. So that will be potentially a little chatty, but you need a way to clear those caches across zones. So.
The other thing to mention, if if anybody is still, on that topic, what Daniel was mentioning, when the number or the listing of nodes in your membership is wrong, one of the other things we found out was if you leave the internal compactor that's built into Kazoo on, because there never used to be a compactor built into BigCouch. There is now a compactor built into CouchDB, and you can schedule it and tell it what the triggers are, like at what % fragmentation to start running. It does its own automatic scanning, but if you leave the Kazoo one on, or if you leave, or if you have anything like we do that actually attaches to the Erlang VM that Couch runs in to, say, grab Erlang memory statistics or processor or like process count or anything like that. Anytime a node, including the compactor or a stats collector, for example, connects to the Erlang VM, CouchDB considers it a node, like a membership node joining or leaving. When that event happens, and this was the case in BigCouch and it is the case in CouchDB, but only now CouchDB logs it and says what it's doing. That's considered a node joining or leaving, and then causes what they call cluster instability. So when that happens, it goes, oh, okay, shit, a node just joined. Let's stop all of our replication. Let's stop all of our clustering momentarily and do a sweep over all the databases to see if there are any changes. And if it's constantly joining and leaving and joining and leaving, you're going to have bad time.
Yeah, bad time. Yeah, actually taking that out made a huge dent, I think, in our CPU on those machines. Is that right?
Yeah, it was about a 60% reduction of CPU.
That's just with periodic polling from a node joining, getting Erlang statistics. So, yeah, wow. Any other questions?
I'm curious about this idea to move MongoDB to Postgres. So the idea is maybe to implement the new abstraction layer that we have for databases.
That's right. Yeah.
Okay.
So yeah, I mean, we'll take KZ Data Manager. We'll add some data plan extensions to make it possible to just say, like, globally, I want all MODBs to default to using the PostgreSQL backend. Cool. And then obviously it's not schemaless at that point. So what it was going to be is run a series of schema files that map very common fields into their own columns in SQL, and then still have some. In PostgreSQL, you can have actually JSON format columns, so we'll leave those for things like custom channel bars or stuff like that that's free form. So
that's great. Have you guys thought about maybe dropping in CouchDB instead of Postgres?
Haven't.
So Cockroach is trying to solve a lot of the same problems that CouchDB has. Their specialty is around large latency geographical sharding.
It's built off the same white paper that Google Spanner, Cloud Spanner built off of.
Exactly. So in 2.0 now, they've started supporting JSON-B with reverse indexes within the JSONs as well as schema-based conventional tables. But it's all written in Go. The backend's totally different. It just speaks to Postgres client. So whatever is built, if it speaks to Postgres, it hopefully would be portable as long as we're not relying on specific SQL inside of Postgres.
Right.
But I just wanted to draw your attention to that project because it's a NoSQL, new SQL approach to the same problems that we're seeing in Couch.
Okay. Yeah, check it out then.
Yeah,
Cool.
definitely.
Cool. And maybe we can help.
Yeah.
Cool.
Thanks, Dan.